We are now going to start with a series of true or false questions. Let us start with the simplest possible question one can ask on empty sets. You have an empty set, phi, which is denoted by simply open flower bracket and close flower bracket. And that's it. Nothing's inside. Now this will be denoted by phi, which stands for an empty set. Now my question happens to be this. Is phi an element of a set containing phi? Now this is obviously true. Why is that? Don't you think this resembles A belongs to a set containing A? Irrespective of what phi is, phi stands for an empty set, but phi is an object. And you are considering a set containing one object, and that object happens to be phi, irrespective of what phi denotes. You should say, yes, this is true, because phi does belong to this set containing one element phi. A set containing phi, does it belong to this set? A set containing phi and phi. Look at this carefully. This set containing phi does indeed belong to this set because it is there as an element of this set, and hence this is true. Here is a tricky question. A set A comprises of an element 1 and an element which happens to be a set containing 1. Now, these things are all very confusing. It doesn't mean that if you don't get these right, you don't know set theory, but it is a true test of your complete understanding, proper understanding of set theory. Alright, so my question would be, do you think a singleton set with one element, namely 1, belongs to A? Is this true? That 1 belongs to A? Absolutely yes. Here is an element of A, and this element does indeed belong to A. So this is true. Next, I'm saying a singleton 1. By singleton, we mean a set comprising only one element. Singleton 1 means a set comprising only one element, and that one happens to be this element 1. So is it a subset of A? Yes, it is a subset of A. Why? That's because if you consider this element alone, number 1, and put that in a set, this happens to be a subset of this set. Correct? Set A. And hence, this is also true. Fourth question. Empty set belongs to a set containing 0. Now, this is not true. Why is that? That's because you do not spot a phi in the set. Right? And hence, this is indeed false. This takes a minute to sink in. Many people would think, but an empty set is obviously there in the set. No, by definition, we don't consider an empty set to belong to a set. In fact, an empty set is a subset of any set. Correct? Why is that? A set containing no elements is obviously a subset of any set that you can think of. By definition of subsets. Correct? So the answer is false. Okay, look at this question. Stare at this question. I'm not going to state this question. Stating would be complicated from now on. So you stare at the question and you tell me whether it's a subset or not. The left side, which is basically a set containing an empty set. Now that's why I said I'm not going to recite the question. It's getting complicated. Is it a subset of this? A set containing an empty set and an empty set? Yes, it is indeed, because let me now write down a set containing A. Don't you think it's a subset of a set containing A and another element B? That's true, because you pick this element set containing A and you put that into a new set, which makes it start flower bracket, again start flower bracket, put a end flower bracket, end flower bracket. this obviously is a subset of this set. So, on very similar grounds, the given question is indeed true. A set comprising of an empty set and that within a set, that is an element within a set, is indeed a subset of a set containing null set and a null set. So here is a bouncer question. Stare at the question. The element 2 belongs to the set. Do you spot this element 2 anywhere in the set? No. A set containing 2 is different from the element 2. Correct? So 2 does not belong to this set. So this should be false. As I said, this comes with little bit of wisdom. There's nothing complicated about this, but it demands that you give it a thought and you should not jump into conclusions. Look at this question. Is empty set a subset of a set containing 0? Now, if someone were to ask, does empty set belong to a set containing 0? I would say no, that's not true. But all that we are asking here is if an empty set, is it a subset of a set containing 0? In fact, we discussed already that empty set is indeed a subset of any possible set that you can think of. In particular, a set comprising of 0 is no exception. So indeed, an empty set is a subset of a set containing 0. So this happens to be true without doubt.